let's look at this question under linear kinematics. This is the episode number 4 on the applications of what? Differentiation. So a particle projected from a fixed point with velocity of 10 meters per second moves in a straight line such that its velocity after time t seconds is given as v equals to bt squared plus 7t plus c, where b and a are constant. 1 second after projection, its acceleration is 1 meter per second squared. So we have to find the values of b and c and find the time the particle is momentarily what? At rest. So if that is the case, let's start from the beginning. So if you have a particle that is moving in a straight line with a velocity at 10 meters per second, and if this velocity is given to you as, let's say, bt squared 7t plus c. Now when the body is starting, at the point that the body is starting, at that starting point, the time there is going to be what? 0 seconds. It's yet to take start. So at the point where we have the particle being projected from a fixed point, from that fixed point that the body is living or the particle is living, it possesses a time of what? 0. So if the time is 0, then the velocity at that time is what? 10 meters per second. So we can use this to substitute into the equation for the velocity to find the constant. So we can say that given our v equals to bt squared 7t plus what? C, then we have what? The initial velocity is given as what? 10 meters per second, and that means the time is what? 0. At that time where the body is about to start, the time will be 0. So in that case, if I do substitution, it means v is going to be 10 initial, then t is going to be 0, right? Plus 7, 0 plus c. All this is going to be 0, meaning your c become what? 10. That information help us find the c. So what is needed next is to find the b. And that information we have ended somewhere here. That help us to find the b, the c. The next information, 1 second after projection, its acceleration is 1 meter per second squared. So we need to also know the acceleration of the body or the particle as it starts the projection. So here we know that acceleration which we use a is equals to dv over what? dt. That is the differentiation of the velocity with respect to time. So our a will now become differentiation of v. If we differentiate, it becomes 2bt. The variable have a power of 2. We subtract 1 from it, it gives you 1. Then plus 7t raised to the power 0. That will be t. This is the constant, so we give you what? 0. So we have this. And the velocity, the acceleration at that time is also 1 meter per second squared. So at t equals to, at a, we have a equals to what? 1 meter per second squared. T is also what? 1 second. We are told 1 second after. So t will be 1 second. The acceleration will be 1 second. So substitution help us to have 1 equals to 2b1 plus what? 7. I believe this will remain 2b, right? Then this will be coming here to become 1 minus 7 equals to 2b minus 6, right? So we divide by 2, b is also giving us what? Minus 2. So now we know the b as the question requires. We need a c also. So we can say therefore, let's just take it here. Therefore, v is going to be b, which is minus 2, right? No, 2 is divided, so minus 3. So we have minus 3 t squared plus 7t plus what? 10. That becomes the equation of the velocity in terms of t, taking away the b and c. So here we have to find the time when the particle is momentarily what? At rest. When the body is at rest, the velocity is going to be 0. So at rest, v will be equal to 0, meaning minus 3t squared plus 7t plus 10 equals to what? 0. So this becomes a quadratic equation. We pick the negative in front to multiply this. So negative 3 times 10, that will be negative 30. We are looking for factors of negative 30. When you add, you get a positive 7. So we can have 10 and 3 itself. 10 and 3, where 10 will be positive, the 3 will be negative. That will give you a positive. So we can put that into it and see. So here, our minus t squared will take the minus 3t plus 10t plus 10 equals to 0. Remember the factors we have of minus 3 and 10. Their addition give us positive 7. Their product give us what? Negative 30. So let's take the first two. This is going to be minus 3t plus 10t plus 10 equals to 0. You can as well use calculator to get your answer direct from here, but we can still expand. Common factor is going to be minus 3t. When you divide it here, you get positive t plus. Because negative 3t divided by negative 3t give you 1 as positive. Common factor will be 10. Dividing this by 10, you get t. 10 divided by 10, 1. Give you 0. So now you can see t plus 1 is not a common factor. We can take out. Dividing this will give you minus 3t. Dividing this will give you plus what? 10 equals to 0. So this product simply means t plus 1 is 0 or minus t 3t plus 10 equals to 0. So transpose and get your time to be minus 1. You get your time here to be, so minus 10 divided by what? Minus 3. And that will give you 10 divided by 3. So from here we can say that, therefore, the time t is going to be, we can write it this way, or 3 whole number, 1 over 3 what? Seconds. Remember, we are not going to pick the negative because we don't have a negative time. We are dealing with time. So we pick the positive and you go to negative. So this becomes the time when the acceleration is what? 1 meter per second squared. Share, like, and subscribe.